Hello students. How are you today? Now we are going to learn about gas. The learning outcomes in this subtopic are: in this video, we will focus on the kinetic molecular theory of gases, the gas laws, and Dalton's law. Based on the idea that all gas behave similarly, as far as particle motion is concerned, the scientists developed the kinetic molecular theory of gases. These are the four basic assumptions. The first one: volume of the gas particles is negligible, compared to the volume of its container. Next, the intermolecular forces between the gas molecules are negligible. Next, the average kinetic energy of the gas molecules is proportional to the temperature of the gas. Last one, the collisions between gas particles are elastic. Now, let's continue with the gas law. The first one is Boyle's law. When number of moles of gas and temperature are constant, volume is inversely proportional to the pressure. The general relation between volume and pressure is PV equals K, where K is the proportionality constant. So, at different pressure and volume, we will get P1V1 equals P2V2. Consider the cute dragon as the pressure, while the four friends as the number of moles of gas. When there are more dragons present, means more pressure, they stay closer together. This shows that at high pressure, volume occupied is lower, and vice versa. Graph of V versus P is a curved graph, and graph of 1 over V versus P is a straight line since pressure is inversely proportional to the volume. For graph of PV versus P, as the pressure increases, volume will decrease at an equal rate. So that's why the value of PV remains constant. The next gas law is Charles' law. Volume is directly proportional to the temperature at constant pressure and number of mole of gas. So, at different volume and temperature, we will get V1 over T1 equals V2 over T2. During hot weather, the four friends standing far from each other. But, in cold weather, they stay closer together. This is an analogy to show the volume is directly proportional to the temperature. Graph of V versus T is a straight line graph, since volume is directly proportional to the temperature. The third gas law is Avogadro's law. It states that, at constant temperature and pressure, volume of gas is directly proportional to the number of moles of the gas. So, at different volume and number of moles of gas, we will get V1 over N1 equals V2 over N2. These two pictures show the relationship between number of moles of gas and volume. The cute rabbit represents number of moles of gas. When we have more rabbit, or more amount of gas, volume will increase. This analogy proves that volume is directly proportional to the number of moles. When we combine these three gas laws, we will get a very important equation, that is, ideal gas equation. This is ideal gas equation. PV equals to nRT. Note that it only applies to ideal gas. Dalton's law states that the total pressure of mixture of non-reacting gases is the sum of the partial pressures exerted by each of the gases in the mixture. This is an example to explain Dalton's law. The total pressure of a gas mixture is the sum of partial pressure of gas A, B, and C. Remember. Avogadro's law, Boyle's law, Charles' law, Dalton's law. Now, let's try to answer these two questions. Number 1, state Boyle's law, Charles' law, and Avogadro's law. Then, write their formulas. Next question, write ideal gas equation.